Hello everyone. We will now examine the individual components of the SmartDrill instrument. 1. Mud shunt. Toe extension rod. 3. Bottom centralizer. 4. Probe rod. 5. Adapter. 6. Top centralizer. These are stabilizer strips. This is also the order for connecting the tool's components from front to back. It should be noted that the communication cable must be pre-connected to the adapter, as it provides both power and data transmission. This is the adapter, and this is the top centralizer. Loosen the fixing bolt at the tail end of the top centralizer. First, thread the communication cable through the inner bore of the fixing bolt. Then pass it through the internal central cavity of the centralizer. The cable will extend from the other end. Ready to be connected to the adapter, strip a section of the outer jacket from the protruding cable. Separate the copper wires into 2 strands. One strand must be threaded through the round hole at the tail end of the adapter. Then, twist the 2 copper strands together tightly. After connecting the copper wire to the tail end of the adapter, it is necessary to wrap it with both waterproof tape and electrical tape to prevent water ingress and short circuits. This is how it looks after being taped and then cut open. You can clearly see how the copper cable is wound, as well as the position and approximate thickness of the waterproof tape wrapping. This is what it looks like after the taping is completed. Then, we will connect the adapter to the top centralizer. Then, we need to securely fasten the clamping bolt at the tail end of the top centralizer. This will prevent the cable from fatiguing and breaking due to rotation. This rear section is what we call the pigtail. This part also needs to be protected with waterproof tape and electrical tape, wrapped into a conical shape. This is the final result. It is important to ensure that the radial dimension of the taped section does not exceed the maximum outer diameter of the centralizer. Additionally, the length of the pigtail must not be too long, as it will interfere with the installation. We will now install the stabilizer strips. As we can see, there are 2 sliders on the centralizer. Before installing the strips, both sliders need to be moved to their end positions. Then, we can proceed with the installation. Once installed, press down firmly by hand to ensure the stabilizer strips are fully seated and properly secured. The rest of the assembly is just simple mechanical connections, so we won't be showing it here. After the whole tool is put together, it's over 2 meters long. So, I'm going to show you with a diagram. Like this. As we can see from right to left, the components are the mud shunt, extension rod, bottom centralizer, and the probe. Next is the adapter. Because both ends of the adapter are already connected to the components in front and behind it, we can only see this short section externally. Following that is the top centralizer, and then the pigtail. After all the guide tools are connected, send the mud shunt into the non-magnetic fixed short sub. Correct the positioning hole on the mud shunt, and tighten them with the fixing screws. Install the guide tool assembly into the non-magnetic drill collar. Secure the drill collar using the tool joint. The entire tool is now fully assembled, and is ready for connection to both the drill bit and the drill pipe. Lastly, I need to stress that, ensure every step of the installation process, to avoid relative displacement between each part of the detector. Here is the assembly diagram of SmartDrill components with pressure module, along with actual product photographs. PWD, pressure measurement while drilling, consists of a pressure module and a fixed sub. It contains 2 pressure sensors measuring internal pipe pressure and annular pressure, respectively. The sensors indirectly contact drilling fluid to obtain readings, which are transmitted to the surface in real time. Surface steering software displays live data, enables high or low pressure alarms for kick risk warning, and calculates mud density and weight on bit based on annular pressure.